Good afternoon to you all. Thank you for being here. It is a pleasure for me to address this welcome to the afternoon session of the Advanced Materials Conference. I think it has been a great day of work in what concerns material science. We ourselves at Nova and at Technical, we are very committed with this initiative that today we are symbolically launched here with this conference in materials. Materials are the basis of everything that we do, of everything which is the base of our way of life. We cannot imagine the future and anything in the future without addressing materials issues such as sustainability, life cycle, environmental impact, development of new materials to address new needs. This conference gathers us here in around this table with the kickoff of something that we are very committed to have in Portugal, a cluster that gathers competencies in material science and engineering, needs in industry, needs for the country, for Europe, for the world, together with our partners and with our friends. Once again, thank you very much for participating with your knowledge, with your experience, with your support. It is very important for us, and I am strongly sure that this will be something that we are proud of in a couple of years, and it can have a strong contribution to what we do in material science, engineering, and development of our society. So thank you to you all, and without any more delays, because I think we are on time, I think we should go on for session 3 of our conference, dedicated to materials as activators and promoters of prosperity and welfare. Our first speaker is Joanna Mendonca. I don't know if Joanna is already here. Okay,
I'm here.
Hello, Joanna.
Hello.
So, Joanna obtained her PhD in Industrial Engineering and Management at Instituto Superior Técnico. She is a professor at the Department of Engineering and Management of Instituto Superior Técnico, where she teaches innovation management and design thinking. She was advisor of the Minister of Economy in 2016. She was advisor of the President of IST until a couple of months ago. And now she is the President of Agência Nacional de Inovação. It is an honor for us to have Joanna with us today. So thank you, Joanna, for being with us, and I give you the word. Thank you.
Thank you, Rogério. It's very nice to actually talk in an event where you are being host. It's an honor to share with you, to be with you in the same panel. And thank you, Rodrigo, and the team for inviting me to participate in this session. I do have some slides just to guide my talk. As you probably heard from Rogério, even though I did have a degree in chemistry, I do have a degree in chemistry. I know very little about materials, so I'd rather leave the more technical issues to the real experts. So I will not talk about materials, but I will talk about the things I know. I always prefer to talk about the things I know. So I was challenged here today to talk a bit about innovation. Thank you to the conference organizers, Sara and João, for sharing my presentation. Apparently I could do it, but I'll talk about a bit innovation and what happens between companies and universities. This is probably one of the most difficult issues, how we manage to collaborate. I've been working on this for many years and realized that in most cases, both companies and universities really want to collaborate, and somehow sometimes the means are there's difficult issues in the collaboration. I think there's an option, João, if I may, where you can choose to
yes, for me is in a full screen, but not for you, sorry.
That's okay. Full screen, no? Does it
full screen mode?
The challenges that we always have, technological challenges, which actually justifies the need for an innovation agency. But if you can pass to the next slide, I just want to talk. I mean, one of the issues in what I usually, when I talk about innovation and why is there such a big interest in innovation, most countries have developed over the years innovation policy. There's deep concern about innovation, and I start with the why. Why do we care about innovation? And actually the reason behind it is that innovation has been related, or the relationship between innovation and economic development has been identified. Back to the development of and to the application of the electric energy, where you can see the big rise in GDP per capita in the world came with the technology. So if you can pass the next slide. And in fact, we can identify these waves of growth, economic growth, with waves of technological development. So throughout history, there has been movements in technology development that have been followed by economic growth. And this relationship, which is not so clear, is what leaves countries to and economies to realize that it's an important investment, innovation. If you can pass the next slide. In fact, when we look at, and again, this is a relationship, there's no causality until now. When we look at the evolution of countries, and the countries that have grown more in terms of GDP are the same that the countries that have invested in R&D. So there seems to be a relationship between the investment in R&D and economic growth. And this is why there's such a big concern in the economies. Of course, again, everything I showed shows no causality. And that's why, if you can pass the next slide, please, that's why economists have actually introduced the innovation in the so-called economic growth models after the 1990s. So actually the development of economic models, economic growth models, have started to introduce technological innovation in the 90s, and have actually in the early 2000s introduced not just innovation, but the actually entrepreneurial activity. And the reason for this was that we could observe that many regions in the world that had high levels of investment in R&D didn't have so much growth as other countries that, although had high levels of R&D, higher, were not as high. And one of the reasons was this passage, precisely this transfer of technology to the market. So next slide, please. So having this idea, we come across another problem, which is the meaning of the word innovation. And why do I bring this? Because actually innovation is a word, I like to say it's one of those buzzwords. We use it for everything. But when we are talking to experts, to R&D experts, looking at materials specifically, but it could be applied to other things, we have to understand this differentiation of innovation with other concepts. So innovation is actually has a wide variety of activities, including organizational issues, experimentation. They have been developed and classified by many manuals of the OECD. The Frascati manual develops the R&D. So there's a difference between R&D and innovation. They're not synonymous. And the best definition I usually bring, if you can give the next slide, is the following: the innovation only happens in the market. So we actually only call innovation what is being commercialized, independently in what way it is. So we can have a lot of R&D, but without the commercialization, that's where the value is. And that's precisely where we need to bring together very high knowledge, high levels of knowledge with the industry and companies and the market, which can bring this knowledge to the market. That's why this connection is so important, because if we don't have this connection, the knowledge is not transferred. So we have really high levels of R&D, really good science, and then low levels of commercialization. And that's where the problem is. So that's where actually the innovation spectrum appears. That's exactly what the innovation agency does. If you can put the next slide, please. So actually, when we look at innovation, this is something I say many times. In the first theories of innovation in the 50s and 1950s started explaining innovation with this idea that if we do research, then research will go on through a linear path until it reaches the market. And so as long as we keep doing research, there will be a path until the market. Next slide, please. There was actually then development of these linear models, so-called linear models, because it's not very clear if they are responding, if this linearity, if this approach to the market comes from as a result of the technological developments, or in fact comes from a market need that is being generated. And so two parallel explanations occurred based on these two concepts, that it could be technological push or market pull. Next slide, please. There was then a development of the models that reached, I will not guide you through all the models, but Klein and Rosenberg finally had what is so-called, it was huge development because started seeing innovation not as a linear process, but as a process with a lot of interactions, which means that actually research and development does not appear just in one end of the process, but follows the process entirely from the idea until the market. And so this was a big breakthrough in innovation theories. And then after that, a series of models followed. If you can put the next slide, please. Including one of the most famous ones, the so-called triple helix innovation model, where you have different actors that take place in the innovation spectrum. Actually, we have in the academia, where you have R&D centers and education, the industry, the companies, etc. And of course, the government with the policy issues. They all have a role in promoting innovation, and it's for innovation to occur, it occurs within this spectrum. Next slide, please. There was then a lot of different variations of this model, this triple helix model. Actually, there's one already with the quadruple, and after that, there was a concern that actually this model did not include the population, the people that are outside the system, and that's how it evolved for the so-called open innovation models, which include the users, the individuals outside this innovation system. So this is just the evolution of the innovation models. Why do I bring this up? If I show you, can you pass the next slide, please? If I show you the innovation agency, actually the mission is to promote innovation. In this, that occurs in this space, on the one hand, you need the research, and there's of course other people and institutions that develop research and fund research. We need the companies to be able to absorb this knowledge, and then we need to promote the transfer of knowledge between one place and the other. Next slide, please. And that's precisely the role of an innovation agency in Portugal and elsewhere, which is to promote the engagement of this collaboration in order to develop innovation, bring innovation to the market. And we do that with different instruments, promoting the promotion or fostering the promotion of R&D projects, enhancing R&D results, developing and supporting technology infrastructures, and also demonstration and pilots. Of course, there's not one way of bringing knowledge to the market, also because different knowledge areas, and of course here we are focusing on materials, but even within the materials there's a wide spectrum, and so different processes, different R&D fields require different methods to engage in the market, also due to the maturity levels, regulation, and this framework is outside the scope of course of the innovation agency, but it interacts with other institutions, and that's why this system appears to be so complex. Next slide, please. So we actually do this based on 3 types of mechanisms. On one hand, this funding R&D and innovation projects, mostly in co-promotion methods. On the other hand, building capacity with the support to infrastructures on one hand, and the other one supporting valorization of technology. And then, of course, engaging in an international space by promoting the participation of Portuguese institutions, all types of institutions, considering the entire system, whether they are universities, companies, or network institutions. Next slide, please. So we have these 3 mechanisms. They have reached high levels of numbers when we look at the Portuguese support in this area in the last few years, which include, of course, as you can see, not just almost 2,000 companies, but the same number of non-companies of other institutions. This is really the collaborative approach to innovation. Next slide, please. Of course, for that, there's also a network of what's the so-called technological infrastructures. Even though this seems like a high number for a small country, this includes different infrastructures. You might ask why we need such a large number of types of infrastructures, but actually with the maturity of the system, there is also a need to diversify the type of infrastructures. Because, for instance, here we are including the technology transfer offices within universities. They are also infrastructures that are part of the system to transfer this knowledge in a certain way. Science technological parks have their own role, incubators, and then the technological centers and the so-called collaborative laboratories, which are all part of this diverse ecosystem of innovation that intends to promote and enhance the collaboration between companies and universities. Next slide, please. So this means that we have a network of what are called interface centers. Most of these centers are of, many of these centers are of either technological nature, focusing on one group of technologies, or sector oriented, which give support to a specific sector, and have a regionally distributed network. And they're also supported by the Innovation Agency. Next slide, please. And then more of a transversal nature are the collaborative laboratories, which are based on thematic issues. So they are developed to address key issues, thematic that address challenges of the future to come, considering a technological roadmap in different areas. Next slide, please. Very relevant is, of course, this diversity and maturity increase of the system also allowed to increase participation of Portuguese institutions in the European programs, and this has been a very high development in the Horizon 2020 when compared to the previous program, and the goal is to increase even more in the next in the Horizon Europe program. And for that we developed some support system that includes not only universities and companies and also these research interface centers that require sometimes support to engage with international networks. Naturally, by nature, the scientific institutions already have established international networks, but some either newcomers or to enlarge the system in higher education institutions or other institutions that are not yet in the maturity stage, we promote this engagement within these institutions. Next slide, please. I'm almost finished. Just a summary of the Portuguese participation. As you can see, it's been distributed, although 37% is from research centers and 26%, 27% are from higher education. We do have a part of small, medium-sized firms of 16%, and large companies 10%, and then the others include these technological centers. So as you can see, we still have room to grow, even though we have a high level of performance by most higher education institutions. We have room to grow also in them, but in other institutions, and of course also in the coordination. And here materials are part of the policy for the next program, the Horizon Europe. Next slide, please. In fact, when we look at just materials specific, including nanotechnologies, processes and applications, the investment in the Horizon Europe was considerable, with more than 16 projects at the volume of 3.9 billion euros. And Portugal participated in 136 projects, which reveals quite a big participation considering the entire program. And this supported 77 million euros of funding. But now, addressing the Horizon Europe challenges, there are priorities for materials, which of course I'm sure that we will have chances to address and compete and bring again innovation to the market, continuing to support our base, but promoting more innovation to the market in the materials science. Next slide, and it's my last slide. I just wanted to show you that this view of the system has to be, in my view, open to all the phases of the system. The innovation agency and innovation agencies overall have a very specific field of where they act, just putting together science and the market. So this is our role, precisely promoting innovation. And of course, you are welcome to send me any email or bring me any questions about this. And this is where I finish. So thank you so much for the invitation and for participating in this forum.
Okay, thank you so much for your very nice and important presentation, Joanna. Although we are a little bit delayed, I think we can leave 1 or 2 minutes for a question to Joanna Mendonca. So
can I put a question?
Of course, Rodrigo.
Yeah.
Please,
Okay.
please.
So I think that you show quite well what should be the intention. Something is value if the market accepts it. This is the message that you pass. But typically, when you are engaged in passing to the market, so to fill in the gap that we have, sometimes you can have some surprises. For instance, something that I believe is not properly addressed either at the national level or at European level, so the message is for TH, is that we don't take care about the IPR. For instance, when we go for patent issues, I think this should be something that either at the national level or at the European level, you could fill in the gap of science by trying to take care about license, because otherwise you can develop a strong product, but at the end, if it is not protected, then you fail to go to the market, even if is something that is demanded by the market. So I cannot understand why we don't solve this problem.
Joanna, can you answer in 10 seconds? Because I have whole backdrop also with a short question and we should move on.
Yeah,
Joanna.
first I should say that you are absolutely right. Innovation is a risky business, and we know that 97% of innovations fail. So and that's why, of course, then the government and policies play a role in decreasing risk for companies. If not, nobody would innovate. With intellectual property issues, even though we do have measures here at the Innovation Agency to help and support intellectual property activities, this is, of course, an issue that depends a lot, again, on the sector and on the dynamics of each sector. But this is a recommendation that can be done formally to.
Thank you, Joanna. So, Wolf, can you just make a very short and final question to Joanna, because we should move on. You have your microphone disconnected. Okay.
So, okay. Short question. The safety of materials for human and the environment is a very important issue with regard to the Green Deal. In your innovation model, how do you ensure the involvement of corresponding expertise on this matter? This often is a lack because material science does work alone and the safety scientists work alone and they don't work together. Do you have an idea for this?
I think that the issue is not just for material science. In fact, sometimes there's these cultural issues of how we can promote working more in a network base. In fact, me and Rogério have addressed this issue when we were looking at in IST at some of the barriers for innovation is precisely this network engagement. And so this is not specifically of material science. I think this is a shift. I think there's a paradigm shift in scientific activity, which is evolved from a very individual activity to a more group network activity. And the speed of this shift is not the same in all scientific fields. Of course, the European Green Deal is a big issue. We have been increasing our support here. We have a lot of activity here. And for the moment, we have not felt lack of specialists, but I might regret this sentence in 6 months. I hope not, but I have not felt the lack of specialists here at the moment.
Okay, thank you. So I have a couple of questions more from Emmanuel and Ricardo, I think, but we should move on. At the end of the session, if we have some time, we can get back to these questions. Otherwise, I will be fired as chairman of this session. So thank you, Joanna. Thank you very much. I wish you good luck and an extraordinary presidency of Agência Nacional de Inovação. We all need your work and your capacity. So thank you. So we move on for our next speaker, which is Jürgen Tietje. I don't know if I pronounce correctly the name, but Jürgen is a lawyer and he works at the European Commission since '92. Presently, he is the head of the Unit of Industrial Transformation, the GRTD, of the European Commission. So it is a pleasure for us and an honor for us to have you here with us, especially because I think we haven't got any other lawyer besides you in this session. So thank you for being here, and I give you the speech. Please, Jürgen.
Okay. Yeah, good afternoon, colleagues. Don't get worried that I'm a lawyer and that I will give you now a speech about law. I think it's actually a great pleasure to be with you. And the first compliment goes actually to the organizers, because I don't know how you managed, because today we published all the work programs, the first work programs for Horizon Europe. So this has nothing to do with law. It's, for me, fantastic how you managed this date, and I'm so proud to announce it. I prepared a few slides, and it would be nice if colleagues can help me with showing these slides. I'm looking at my screen.
Yes, you have a green button.
I should do
button.
it. No, I've not made them. Oh, okay. Okay, let me see whether I can manage.
Yes, you can click on share screen button and choose what you want to share.
I will. Hopefully it works. Can you see them?
Yes, yes.
Okay, good. I'm here in this session and I'm going actually straight to...
Sorry, please put on the full screen.
And this, I don't know how to do it. Okay, can you see it at least?
Yes, you have a slideshow on the top of your screen. Slideshow option, yes.
Thank you. We're getting there. You see one.
And yes.
Yeah. Okay. Good. We're getting there. Okay. Good. That's why I'm here. So I'm heading here of a team of 22 people who are all more intelligent than I am. So reassured engineers, life scientists, and who helped us devising this fantastic work program, which is out. You find here a link to the work program, which has been published. So in my speech today, I need to be on the one hand very practical, and I don't have the time as well as to prepare you to show you all the work program. On the other hand, I would like to give you some thoughts also where we should think ahead, because I'm fully conscious that people are now very busy in preparing proposals. The call deadline is the 23rd of September, which is very short. But we have even been already asked to start thinking, okay, what about the work program 2023, 2024? So for me, it's a big challenge to build the graph, but I will try to be very practical. So the first point I would really like to share with you, and this is already online available, we plan digital info days on the 29th and the 30th of June. Here, we will make in the next days actually available films and slides. People should start registering on this. If you type on it Info Days Horizon Europe, you find it immediately. And you find it here also at the bottom of my slide. We expect thousands of people to listen in, to ask us questions. On industrial technologies, it will be more on the 29th. On materials, we will have a half-a-day session on answering questions to all topics which we have put forward. I think it's a massive investment we are putting forward now. If I look at it, the total budget for all cluster work programs, we are speaking about 10.5 billion euros. For this cluster 4, it's 3.5 billion euros. And for advanced materials, it's 420 million euros. On the 29th and the 30th of June, we will present the 2021 topics. We will not focus already on 2022. People have a little bit more time to prepare. But sorry for coming in with this breaking news. You will forgive me that I'm so dense and so packed, but it's of course for me the opportunity to spread the news. And again, my compliment to you as an organizer. How did you manage actually to place the date of this conference at the same date when we publish the work program? I didn't know, somehow you know, apparently. So it's a real magic how you put this together. Let me go now a little bit more into the detail, because, and this is actually cluster 4, in industry being the motor of growth and prosperity in Europe. And this is a bit more further thinking. For us, the upcoming work is not only to think about materials are everywhere, but also to think much more about downstream applications for advanced materials. You will see, and this is a famous quote from Ursula von der Leyen, you will see in cluster 4 overall a logic where you think about competitive technologies respecting the boundaries of our planet and reflecting human needs. This is a Green Deal, but also the recovery plan. So people should bear in mind that we are working much more in a context here, and this drives much more the work programs. We have the climate neutral and circular and clean industries, but we have also a lot of digital transformation in this cluster 4, and it's one program. You have no longer NMBP, you have no longer ICT, you have no longer specific program and raw materials. It's all putting together, but I will guide you a little bit further. What for us is very important is also the contributions each topic should play to inclusiveness and resilience. So when it comes to engagement with workers, citizens, and development of skills, but also engaging with regions. So the approach is different. For us, it's a big experiment. We'll see which questions we will get on the 29th and the 30th of June. And this is an overview. So the overall budget for 7 years is more than 15 billion euros. You should not worry anything what you hear about the next generation for the European Union, which is a specific budget. This has no specific impact for you on the individual topics, so you shouldn't worry about it. And we have a programmable budget, as I said, of 3.5 billion euros. And there you find here destinations for the budget 2021 and 2022. You have 4 production technologies. These are the energy intensive industries, the discrete manufacturers, the construction, but also the steel sector, which you find in a first destination where you have a budget foreseen for 2021 of 2022, 740 million euros. Very important for you is the destination on autonomy and strategic value chains for resilience industry, because here you find both raw materials, but also a block of topics for advanced materials representing the 420 billion euros I was suggesting to you. So this is just a key overview, and I'm sure you will see it also during the info days, but I wanted to confront you with this is where we are. You have other destinations, this concerns data. You have digital and emerging technologies for competitiveness. We have the questions about space, and we have an action about human-centered and the ethical development of digital industrial technologies. Advanced materials are sitting in the destination, increased autonomy and key strategic value chains for resilient industries. Let me go now a little bit more into deeper, and I think you have given me 10-15 minutes, and that's of course a challenge to present all the topics, but a few thoughts. First of all, we are living really in the world of a twin transition, green and digital. Things should be thought together. And this is really governing the principle of destination 1 and destination 2 I was referring to. Be aware and that's our firm belief, 70% of the innovations come also from advanced materials. And I confirm our commitments that key enabling technologies, this remains a valid concept, and advanced materials are part of it. And here's a journey for prosperity really starts for us. Rising sustainability and digitization challenges for the industry. You will find here topics about energy-related applications, including for hydrogen or material for the hydrogen transport. But you will find also something new, and this was already hinted at. This is the concept of safe and sustainable by design. So this is a new concept we want to push also for research innovation, and we start at the design phase. And we have put forward two topics here, one on polymeric materials and the other one on metallic coatings and engineered surfaces, that people should start thinking about not only on safety aspects for consumers, safety aspects for health, but also in terms of sustainability, what it means in terms of circularity, but also in terms of cost efficiency. So it's a new concept we want to push, which is coming from DG, not only from research innovation, but it's actually driven by the chemical strategy. How do you deal in future with chemicals, and how do you deal with chemicals, and how do you deal with them when it comes to advanced materials? And there's an important CSA, which I would like to promote as well. I would like to set up a new community of experts, of high-level experts, focusing on safe and sustainable by design. So that's something really new. On digitalization, we continue our agendas on industry commons. Industry commons, where we think we need a methodology for communicating about data. And we all know we are living today in a data economy. And if you're working with advanced materials, can you really ignore data science? No. And that's not only modeling and simulations, and goes far beyond. So these are elements which you find in the work program and will be discussed during the info days on the 30th of June. Let me come to an element which might be a bit surprising for you, but I think it's important. And here we are thinking a bit beyond the work program. Digitization, advanced materials and digitization. Is this a game changer in Halsey's agenda? And should we actually embark a bit on a future strategic discussions on advanced materials here? You have digitalization. It's linked to the developer of new materials when it comes to computational and experimental material science, modeling, digital modeling, simulation opens the way to the design of new advanced materials with targeted functionalities. How can we accelerate this? We have also digitalization, which accelerates knowledge diffusion and valorization. It's another element which I would like to bring forward, and just to throw it at you, but to give you an insight, I think that we need to think in the materials community also more, where can we combine digitization with what is happening? We have the digitalization also when it comes to disruptive technologies, materials and quantum computing, 3D printing, AI, Internet of Things. How can we create more synergies? That is something where we are at the beginning of our thinking. It's not in the work program for 2021, 2022. It's the beginning of our thinking. I felt, why not sharing it, since you have given me the unique opportunity? And the last example, of course, we should think about when it comes to digitization. It is the automation of production processes. Advanced materials represent a growing share in the cost of digital technologies components. So what I would like to invite you is, and this brings me a bit to summary of what I tried to say, and sorry, I hope I respected my time. First, the work program for 2021-2022 has been launched. We are planning info days on the 29th and the 30th of June. Please register. There will be soon a Slido option. People can very concrete questions, and there we will go through topic by topic, and you get all the information you need. We have a call deadline for the 23rd of June. I was trying to shed some light on the priorities. So the most important one is that you set in this destination, about destination 2, value chains. There you will find the information. This is where we are, and that will trigger you to roll up your sleeves and to work hard for successful proposals. It's a challenge, but we're here to guide via an info day, via the national contact points, which will continue to work as they are, also via partnerships, to have a successful set of proposals by the 23rd of June. The next point is for us to think a bit broader, and you find the ingredients in this work program, one on digitization, the other one on safe and sustainable by design. You have energy-related applications as well, so it's a whole mixture. Safe and sustainable by design will continue accompanying us in the process also for future work programs. So this is a long-term agenda. Digitization, we are at the beginning, but we think it's also a long-term agenda where we would like to invite you from the materials community engage more with us, what could be done here in this regard. I know, Rogerio, this was a very dense presentation, but it was a great pleasure actually to throw it at you and to happy questions you might have now and to engage in a discussion with you. Thank you very much.
Thank you so much, Jürgen, for your important and for the opportunity of your communication in the right day. We are a little bit delayed, but anyhow, I can have a small question for Jürgen, if there is one. Or
can I put just a question? First of all, thank you for your and you see we are on the target, on the spot.
Yes, you are. You are.
Rodrigo,
right. Well done. I don't know how you managed.
Okay, so thank you very much, Jürgen, for being here with us. So we will move on to the next speaker, which is Ellen Cry. Ellen is head of the unit of Clean Energy Transition from the European Commission. She is a civil engineer. And Ellen, we will speak about materials to support the clean and sustainable energy transition. So, Ellen, I don't know if you are here.
Ellen, you need to
I think
mute your microphone.
Oh, hello, Ellen. We see you. Thank you for being. Okay, we can hear you now. Thank you so much for being with us. So I give you the speech to you. Thank you.
Thank you very much. I was listening with great attention to what Jürgen said, because I was dealing previously with materials, so I feel at home. Maybe we can put the slides. Would you mind?
Second.
Yeah, thank you very much. So this is now looking at energy. And why energy? Because energy, whether it is produced or consumed or whatsoever, it represents 3/4 of the emissions, negative emissions on the climate. So without looking at energy in transport and energy in buildings and so on, the overall load of the economy, which is energy, represents the major impact. And the first and foremost way to mitigate the climate in the long run is to switch to a clean energy. But that will need a lot of things. And first of all, and that's why it's so important to speak on materials for energy transition, it needs to change a lot of equipment. If you consider, for instance, that there is around 1 billion cars, private cars in the EU, you have to change all. If you, and they will not be changed normally, I mean, because of their obsolescence, they will be changed because they will need to switch to clean energy. Now, if we look on windmills, on solar fuels, on all that type of things, the cost in materials will be enormous because we need to do a lot. And that is a worry. That's why we speak on materials in the clean energy transition, because it will have an impact simply on the resources of the planet and also an impact on the dependence of the EU towards these materials. So next slide, please. Yeah. The global context for the energy sector, it's well known, but what I would like to remind is the objective. These 4 words have, I think I'm again muted. Or do you hear me?
Yes.
Okay. I got a message that I was muted, so I did not understand. So the 4 words which are in the previous slide, which are safe, secure, sustainable, and affordable, are all equally important. Should be safe, meaning that we should care about protecting the people. Should be secure, should be granted also. We need to look at the security of the autonomy of the EU, but it should be sustainable. I was very happy to hear Jürgen, because we put the first time the concept of circularity by design for materials in the NMBP, the previous Horizon 2020. And at that time, that was looking like something really strange, and we need a lot of people to be convinced. It's now flying, and this is great, really. I was speaking about that with our Director General yesterday, and he was very happy to see that we have been able in DG R&I to influence the reality with that. So sustainable and affordable, because we care about people. Energy is the blood of the economy, not only for industry, but for people living, for normal ways of life. So you know that it has also a lot of impact on employment, but also, of course, on materials itself. One point has to be flagged is that without developing substantially renewable energy, we will simply not reach the targets for 2030 and 2050. It's a very basic thing. Whatever we do as energy efficiency or as switching or reducing the use, I mean, whatever we do on the side of the demand, the first and foremost thing we need to do is to switch to clean energy. This is something which should be hammered, because as we look a lot about switching transport to this and switching industry to that, we forget that the main thing is to change the energy itself. Next, please. So the challenges, of course, the Green Deal, and I think Jürgen explained that, so I will not come back, except that the 55, the Fit for 55 includes a lot of things on energy, a lot of revision of tools, of directives and regulation. We quoted here, for instance, the Renewable Energy Directive, but there is also the Energy Performance in Building. There is the ETS. There is the CBAM. I mean, all these acronyms cover a system where we are trying to orient the economy towards paying the fair price for energy. And paying the fair price means that it is leading to switch to renewable energy. Next, please. So the decisive moment, of course, the Recovery Fund, the Fit for 55. In the Green Deal, there are some very important EU strategies. The smart sector integration, of course, also the offshore renewable energy and the hydrogen strategy, as well as the renovation wave. But the Fit for 55 includes also a lot of regulatory tools which are linked to that. And they also have been strongly supported. All these strategies have been strongly supported by research and innovation. I think it's the first time that we have such a strong chapter on research and innovation in each of the strategies on energy. And that represents the fact that, I mean, I hear very often that most of the technologies are mature and we just need to put them on the market. I'm not convinced of that, and we are not convinced of that. That's why you have a strong chapter on energy in all these strategies, because all these approaches of energy, they need a lot to work on increasing efficiency, reducing costs, developing production processes, using materials in a better way, recycling by design, substituting materials to avoid depending on some outside countries. All that is a package which goes to the market and where research and innovation has a strong role to play. Next, please. So the Cluster 5 in Horizon Europe program, the work program was adopted today, so I will not give you a lot of details on that, but give you the main indications, the destination 3 and 4. Next, please. Yeah, so globally, to make a frame, to give you a frame, we have put these 3 parts into the energy supply itself. So the renewable energy, the energy systems, and what is cross-cutting. On the renewable energy, research is also preparing for the long term, for the future. So we put not only solar and wind, but we put between brackets small energy and also bioenergy, because in some cases, bioenergy is the only way we have to make the bridge towards 2050 in a more, let's say, sustainable way. The energy systems, of course, electrification, grids, but also energy storage and carriers. We have very few enablers, technically speaking. We have electricity, we have hydrogen, we have, in a way, and it's linked to hydrogen, ammonia. But we have to develop them for a better use, and we have to develop them being green. This is the approach which is in the hydrogen strategy. Even if in the short run, we can accept not fully green hydrogen with carbon capture and storage. In the long run, it should be green. Having said that, I don't recognize in a fuel cell if it uses green hydrogen or blue hydrogen. This is for the supply side. It's not for the use side, the utilization. That means that we are also working still on carbon capture and storage. This is important because carbon is also a foodstock in a way. And the cross-cutting, they are very important because they show that we are having a horizontal and holistic approach. You know all about the set plan, I'm sure. I will not detail, but the novelty is the ERA, the European Research Area revamped, where there is an ERA pilot on hydrogen, on green hydrogen, which is led by member states, but to which we contribute as Commission with our tools at EU level. We also have an international dimension. If we develop ships with hydrogen, we should be able to have them getting hydrogen in any port in the world, for instance. So all that means that, again, we will not have to use materials for energy inside the EU, but we have to cooperate with the rest of the world on that. We have to harmonize on standards, on certification, on regulatory frame. We have to be sure that when we import hydrogen, green hydrogen, it is green. And we don't exploit outside countries exporting our polluting ways. We have to be sure that when we import green hydrogen, it is carried by ships which are using clean energy and not dirty one. That's all that type of things means that all this work on energy has a strong international component, which is having a strong consistency dimension. We should be consistent at the world level. Next, please. On the side of utilization now, we have a lot to do on buildings. And this has a link, by the way, with the European Bauhaus. For me, having done a little bit of history and having some historian in my family, the Bauhaus is very interesting as an approach because it mixes the aesthetic, the accessibility to everyone, so low cost but good quality, and the use of innovative technologies, innovative materials especially. So the new Bauhaus is building on these 3 pillars: the aesthetic, the affordability, and the innovative materials, the technology, the new technologies. And of course, we have the partnership Built for People. And I think the title describes very well the approach we want to have with that. So on the industry, of course, the industry will be changing its energy. But this is a little bit more taken on board through the other cluster. And especially, I think that Jürgen has been speaking quite a lot about that. and of course, carbon capture and storage. You have here below the split between the various topics. And if you see that we put more on energy supply, it's also because energy use is somehow taken on board partly in other parts of the program. Next, going to the end, yeah. So we speak always about sustainability and circularity. And I think these two designs, they show very well what it means. So circular and the sustainable. This is very important to have both. As my colleagues of DG Environment said, we don't want to exploit waste. We want not to have waste, which is a different approach. And research should build at the beginning with materials that we don't have waste, that at the beginning it is conceived how we will recycle and how we will make all the processes sustainable in the long run. Next, please, because I think I'm running out of time. Yeah, as I said, international collaboration is extremely important. And I would just like to flag mission innovation and the TCP of IEA, the International Energy Agency, where there is a strong component on renewable energy. But there is also quite a lot of work done on materials. Next, please. Yes. So just to alert you that the Info Days will be the 5th and the 6th of July with a brokerage on the 7th for climate, energy, and mobility. Most of the actions on mobility, which are purely energy, are in the destination on energy. So for those who are interested in mobility, they have to go also to the part on energy. As a conclusion, I have worked quite a lot to put the dimension on materials into the energy, and this is now reflected in the work program on the destination for energy in the cluster 5. It is also reflected, if you allow me to give one last example, between on the cooperation between the partnerships. We have quite a lot of partnerships, and we have quite a lot of joint undertakings, 9 if I'm right. In energy, we have one joint undertaking, which is hydrogen. But there are also other joint undertakings and partnerships, co-program partnerships, which are linked to energy. And we have set up an inter-partnership assembly where these partnerships meet and decide jointly who does what, in order that the amount of money which is mobilized on hydrogen is completed by amount of money which is mobilized on the user side, by the maritime partnership, by the waterborne, by the clean aviation, by the process for planet, clean steel, and so on, and go to zero. That's the first block. The second is, the second point of my conclusion is, we cannot do everything at the EU, we have to do it with member states. We already have the set plan, but we have foreseen in our cluster 5 a very big co-fund with member states with a huge amount of money, 6 times what was devoted to Eramet. That's a lot, that's a big increase. And this will be developed in cooperation with member states. There will be joint calls. I would like to stop here. I apologize if I was too long. I'm not sure I was. I will be happy to answer questions. And I was very happy to be invited here because materials remain close to my heart. Thank you very much.
Thank you so much, Hélène. I think we are a little bit out of time, and anyhow, I will give space for one small question to Hélène.
I will. Thank you very much, Hélène. And I know that materials is in your heart. Just a small question. In whatever the roadmap that you gave for energy, there are something that you said that should be global. So I fully agree with you. So don't you think that you need some type of CSA studies, see how Europe could be involved with other continents and in trying to promote something that will impact globally in our society? You know, I think a common global house is necessary.
Yeah, I fully agree with you, but we have it indeed. In energy side, in research and innovation in energy, we want to go global, not bilateral, because the challenge is global. One of the very good approach of frame is mission innovation. I spoke about the mission on hydrogen, but there is not linked, it's not unique. There are many challenges, many implementation group, and simply the one on hydrogen is more advanced. The mission on hydrogen is more advanced, but there is also a mission on power, and there are implementation groups which are working on different sides of energy. This is a way for us to attract the countries and work with them in a light structure. You bring what you want. The second thing is, of course, the association countries. And we have to develop a strong cooperation with association countries, because with association countries, we have the same rules. They sign an agreement implementing the same rules. So we don't have to restrict calls or to do any clause. So I agree with you, but it's also up to the other side to accede, to agree to accede to our system and to do global cooperation. But with mission innovation, it's a good entry point, because mission innovation will lead to some joint calls or multilateral joint calls inside Horizon Europe. There is a link between this global frame and Horizon Europe. This is our tool for enlarging cooperation. Thank you.
Okay, thank you so much, Helene, Rodrigo. So we must move on for our next and last speaker for this session. It's Peter Wellman, the president of the AMRS Society. So Peter Wellman is a physicist. He is a professor at the materials department of the University of Erlangen at Nuremberg. It is an honor for us to have you here with us, Peter. So thank you for being here. And I give you the speech. Thank you so much.
Thank you very much for your nice introduction. Welcome everybody to my presentation. So compared to the last presentations, I think it's more technical, but there is a strong link in particular to the clean energy we have learned a lot about in the last presentation now. I'm a specialist in semiconductor materials, and the topic today is I want to discuss with you beyond silicon, so that we highlight aspects, so what comes beyond silicon that really can use for clean energy and also electrical energy transmission. Now, very short, my activity in my research, it's a so-called Key Enabling Technology Laboratory that we have established at the university. So that's maybe not a normal case, but we are doing a lot of research also for industry. And we are profiting a lot that the university is very strong in innovation and supports us in all these activities like contracts with industry and so on. So this needs like an own framework that such activities are possible. So now going beyond silicon, what does it mean? So silicon, it's well known for microelectronics, for electronics since decades. It's used in photovoltaics and also for sensors. Already since the early 1970s, so about 50 years ago, in parallel to the silicon for optoelectronics, compound semiconductors like gallium arsenide have been used. So it's not only silicon in electronics, there are also some compound semiconductors for optoelectronics and the very high frequency, the very fast transistors like in your cellular phone or in a satellite receiver. Beyond silicon, what does it mean now? It means, for example, looking at the microelectronics and sensors, new materials like graphene, 2D materials that are implemented. So we profit from the new properties. In photovoltaics, of course, we have also thin films, cadmium telluride, so-called 6 materials. In this case, the recycling is very important, particularly with the cadmium. We have concentrator solar cells, compound semiconductors play a role, and so on. Now, another issue, and there we need new properties. This is towards power electronics, also high frequency. And the power electronics we need for this electrical energy transmission. So when we're talking about clean energy, there's the windmill, there's the solar farm, but how to bring the electrical energy now let's say, to the green hydrogen station or to the customer that is using it. So there we need this new kind of materials beyond silicon. And I told you it's a little bit of a technical presentation, but I will not focus on all details. I try to give you an overview so that you get the important ideas, but the details are not so important. So silicon, for a certain strong electrical field in the devices, you have a certain resistance. And you see, you have a quite high resistance compared to other new materials where it goes 3 orders of magnitudes lower. And these are all the materials with so-called wide or ultra-wide band gap. So silicon has a band gap of 1.1 electron volt. The others, not 1 electron volt, it's more like 3, 4, 5 electron volt. And this means also the so-called breakdown voltage, the strength of the field that we can use in a device, it's much higher, 10 times higher than in silicon. For the device, it means it's not that big like in silicon, it's a thin device, like shown here for silicon carbide, which is currently the most successful wide bandgap semiconductor for power electronics. So that's the motivation. And the application for this wide and ultra-wide bandgap materials, they lie in the energy sector. So you will recognize here many applications from clean energy. So for PV inverters, windmills, wind energy, but also fast trains, of course, like for the personal use, the electrical vehicles, the hybrid electrical vehicles. So far, silicon, which with its properties had to cover everything. But for the high electrical voltage and the high current density, so really power, there are other materials, the wide bandgap materials are superior. And it was just a long way so that some of these materials could be developed. At the moment, silicon carbide is the most successful, that covers a very wide range. But very important, gallium nitride plays an important role, I will show you. Gallium oxide is a quite interesting material. It's unclear what will happen, but it's with high potential. But for the future, I mean in 50 or 100 years, diamond is a very nice material. Now, I want to explain to you, again, more like from the basics, what do we have to look at if you want to have a very good material for these applications? We need a high blocking voltage, high heat conductivity, that's important, but for a semiconductor, there are 2 issues that are eminent. It's a so-called doping. We have to tune the electrical conductivity. If you cannot dope, you cannot use the material. And we need perfect crystalline material. So the crystalline lattice, the ordering has to be perfect in the material so the performance is high. Doping means we are putting other atoms into our lattice, N-type and P-type doping. We can form a so-called PN junction. And if it's not possible to do either N-type or P-type, or better both, if it's not possible to do it with a new material, we cannot use it. Crystalline quality, usually the device is just a thin layer on top of our carrier. But defects in the substrate, they distort the device. So at the end, if you want to have a high-performance device, you need a perfect substrate, so the device is also perfect. Now, and this is where silicon actually is the winner in the game, although it's not so nice from its properties for the power applications, because you can produce silicon in a very nice so-called Czochralski process as a perfect material without dislocations. I don't know any other semiconductor material that can be fabricated in such a high quality. So when I'm looking at the other wide bandgap semiconductors that are better for power, we have problems to create such nice material. Why? One important point is silicon is fabricated by melt growth. So you melt silicon, you recrystallize, and this is about 1,500, 1,400 degree in the process. That's not very high. But the ultra-wide bandgap materials, due to their strong lattice often, it's much more problematic. Some of them, most of them we have to go above 2,000 degree. Or if we stay below the 2,000 degree, we have to pay another price. In these systems, chemical resistance is a problem, or you need very high pressures. So it stays very difficult. And due to these problematic properties during fabrication of the material, the material is not so perfect like silicon, but it has very nice properties. I will rush through the materials. Don't worry, it will not be too long. So in silicon carbide, 2,800 degrees where we would decompose the material and heating up, we have to stay below about at 2,200 degree, for example. And this is a crystal boule from my laboratory, 150 millimeter in diameter. That's also the current standard in industry. Industry's quality is a little bit better than my quality in the laboratory, but it shows that we can develop such materials that can be used in industry. This size is already quite nice. And concerning what we can push in the future, so the technology can be developed further, certain applications, like in my laboratory, we have a computed tomography system. So 3D, like if you go to the doctor, but now with a hot zone above 2000 degrees. And this needs certain extra labs that can support industry in their developments. What we can say for silicon carbide, in most fields that we use, that we needed, crystal quality, doping, processing of the devices, is not so bad. It's actually quite mature. Still, there are open questions, but we're in a very good way. Now, the gallium nitride. Gallium nitride is very well known for the blue and green LED. It also can be used for power electronics, but we need a nice substrate. There are two processes today, and both are problematic. In both cases, only thin material can be grown. It's the hydrogenated vapor phase epitaxy, very successful development in Poland, in Warsaw, in this case. The company Amono is another competitor in this field, but using the ammonothermal growth. So in this case, we go to low temperature, but we have to live with very high pressures, a few thousand bar during the process. And currently, this is, in my opinion, one of the best materials you can get. It's not only done in Poland, it's also done in other areas of the world quite nicely. But the wafers are small. And now in gallium nitride, we come back to the silicon. So silicon as a substrate, and people have managed to grow gallium nitride on it. And this shall be applied for medium power applications in the future. So what we can say for gallium nitride, nice crystals, still hard to grow large pools. But all the other aspects, they're quite well developed thanks to the optoelectronic applications. So far in power electronics, only a few devices with high performance have been demonstrated. The gallium oxide, that's a quite interesting material due to its properties with very high breakdown field. People have managed to grow nice boules. Also the epitaxy, the device processing, they have been shown very nice results. But the so-called heat conductivity is low. And therefore, since we have a power device, what to do with the heat? There are some solutions, but it's still unclear to me if this material will be successful due to this physical property. Diamond would be the winner if we go to really high power, to extreme high power. In this case, it's also very difficult to grow it. We know it, jewelry, diamond, we hardly find them. There are very small boules at the moment, or larger crystals with medium quality. So there's a long way to go for the diamond, but I think in the future for extraordinary materials, so for extreme power applications, we should invest in the development. Now to summarize, silicon has covered in the past everything, but today we have a much better choice for the medium and high power, means silicon carbide. Gallium nitride, in particular grown on on silicon wafers, the large area silicon wafers, would be ideal to cover the low and part of the medium voltage range. And this is a very important development. In case of gallium oxide, hard to say where it goes. It will depend not only on physical properties, it also will depend on some other IP questions and so on. Diamond, that's something for the future, but I think we should also support it today. Now, coming from the European Materials Research Society, what is the role of the European Materials Research Society in all this to go beyond silicon? It's a platform where we share new ideas, novel findings in R&D. We can form networks, and we are supporting young talents. This is a picture now from 2019 from one of our meetings. Last year, we had to cancel the meetings. This year, we had a very successful spring meeting, but it was virtually. In the frame of this EMRS, IUMRS, this International Materials Research Exchange, recently we have published kind of perspective article, the search for new materials and the role of novel processing routes. So if you're interested, you can take a look at this link. So it has been published in Springer Nature, Discover Materials recently. With this, I would like to thank you for the attention.
Thank you so much, Peter, for your presentation. So we are a little bit delayed. So Fatima is here. I will propose, Fatima, because we are entering in your session, that we start your session with a small delay of 5 minutes to have time for a short question to Peter, and then for a small break for a coffee. So I will ask anyone for a question to Peter Wellman for a short one. So,
Thank you, Peter, for your very, very interesting talk and quite relevant. Gallium oxide, can you see, when we are looking now for sustainable materials, abundant materials, do you think that this will not be looked as a critical material for the future, or you think that we have space for it?
Do you mean critical because gallium is used?
Yes.
Okay, I don't think that this is a bottleneck, because gallium arsenide, which is the backbone of the red LED and the many laser structures, it also uses gallium. So I think this is not, it's discussed, but I don't think this is the bottleneck. For me, the question is if we can handle the heat. It's a technical question. And then I also think it will depend, like on IP issues. If a company wants to use gallium oxide instead of something else. So I think such decisions will be relevant in the future. It looks very nice, the material.
Okay, thank you so much, Peter. So thank you to all the speakers. So we'll make a short break here of 5 minutes, and then we'll move on for the next session. Before I finish, I just want to notice that we have 122 participants now in this conference, which makes me very happy with it. I think it is a great success, this organization, and I thank the organizers that have this initiative. So thank you to you all, thank you to the speakers, and thank you to the attendants, and we'll make a 5 minutes break now. Thank you.